Welcome to this week's episode of Automation World's Technology Matters. In this episode, we'll be looking at wearable sensor technologies for social distancing, using vision systems to inspect liquids and solids, and the rise of publish-subscribe communication protocols in industrial networking. Now, as much as automation technologies have become pervasive throughout the manufacturing industries, lights-out factories remain a distant idea, meaning that people are still critical to production operations and will be for the foreseeable future. Now, in light of the COVID pandemic, this means that factories must adapt operating practices to allow for social distancing to keep workers safe and their factories up and running. And that's where wearable sensor technologies come in. Several companies have been developing new technologies to help ensure safe distancing is maintained between workers. And they can also be used to track the duration of the worker's proximity and capture data for contact tracing if a worker becomes infected. Now, Automation World recently covered the Fuse wearable sensor designed to ensure that workers don't injure themselves by improperly performing various activities. Now, the company behind Fuse sensors, StrongArm Technologies, has now configured its device for social distancing as well. Now, in this case, the Fuse sensor uses Bluetooth to measure the distance between sensors and can provide vibration, visual, and auditory alerts when sensors get too close. And alerts begin with flashing LEDs and vibrational feedback, and these alerts can escalate to auditory alerts if the worker's position isn't corrected. Now, in addition, the platform's data capture enables contact tracing. Proximity interactions are time-stamped and logged onto the sensors, and daily reporting in the platform can identify non-compliant individuals as well as identify individuals potentially at risk. Meanwhile, Siemens is focusing on using its RTLS, real-time location system technology, which is similar to RFID, but which uses active tags, meaning they have an embedded energy source that enables them to transmit signals on their own. The signal from the transmitter moves out to at least 3 antennas called gateways. Siemens says the transponders will enable distances to be determined down to a foot, ensuring that employees are maintaining safe social distances. The tags can also be set up to start a timer when employees get within 6 feet of one another, allowing the user to determine how long that timer runs before considering it a violation. Now, Conexon Industries has developed Conexon Safe Zone, a wristband that actively warns the user as soon as the minimum physical distance to another person has been compromised. Now, according to Conexon, its SafeTag technology is better suited than the use of smartphone apps for this kind of sensing and tracing, as its use of ultra-wideband is reportedly 10 times more accurate than sensing technologies based on Bluetooth or wide local area networks. Plus, ultra-wideband technology doesn't interfere with other radio technologies that may be in use in a plant. Conexon says its SafeZone technology has already been tested by a top 5 global automotive parts supplier, a top 5 food and beverage company in the U.S., and a top 3 global logistics company. For more information on these technologies, visit the link shown here. Now, in a recent episode of the Automation World Get Your Questions Answered podcast series, we connected with Fernando Callejon and Felix Klebe of Omron Automation to answer a reader's question about using machine vision systems to inspect both liquids and solids. Now, Fernando explained that there's little difference from the hardware and software points of view when it comes to inspecting liquids or solids. He said the same vision system tools will be used, they're just used in different ways. And this is most evident with lighting. For example, a transparent liquid level inspection would normally use a backlight, while solid, opaque label inspections would use a more direct lighting approach. And he also noted that motion can affect your choice of vision systems for liquids and solids inspections. For liquids, a smooth acceleration and constant speed or velocity will help to maintain level and consistent product separation, Fernando said. For solids, the maintenance of speeds isn't as critical because it doesn't tend to change the characteristics of the item to be inspected. Now, as with any automation technology, justifying the investment is always a critical step in the process. So when it comes to vision systems, Fernando highlighted 5 common aspects to consider when looking to determine your return on investment. And those aspects are repeatability of inspection and consistent judgments, speed of inspection to avoid bottlenecks on the manufacturing line, net content control and waste management. And Fernando says this is key to maintaining labeled amounts to avoid penalties and waste, labor cost. And here Fernando said to think about how you could repurpose inspection operators into higher level value-added activities once you have a vision system for inspection. This is particularly important today in light of COVID-19, as the use of vision systems can help reduce human contact. And finally, Fernando said to consider initial capital equipment costs and engineering costs. Now, to hear all of Fernando's and Felix's insights on machine vision system use for inspections, access the podcast at the URL shown here. Now, amid all the industry buzz over the industrial Internet of Things and Industry 4.0, it's clear that new ways for communicating all the data associated with these initiatives is needed. And one clear way this is happening is through a move away from the client-server approach and toward the publish-subscribe model, more commonly referred to as pub-sub. And while there's much to be said about the pub-sub model, an essential point is that it decouples industrial devices from the applications used to access data from those devices. Pub-sub does this by using a central server to receive all the data from devices, while clients subscribe to the server to get the data they want. This message broker server automatically routes the appropriate data to all subscribers, eliminating the constant polling of devices for message updates, as is typical in a client-server setup. Another important aspect of the pub-sub model is that data is only communicated when it changes. Static data isn't repeatedly sent. This significantly reduces network traffic, and the network architecture is also streamlined because instead of one device needing to communicate with dozens of other devices or applications that want its data, communication is established via a single server that relays information to any device or application that wants it, leaving the industrial device to simply do what it was designed to do. Now, the two most prominent pub-sub technologies for the industrial market are message queuing telemetry transport, better known by its acronym MQTT, and the OPC unified architecture with pub-sub support. Now, MQTT is an open-source messaging middleware specification that's become very popular in the enterprise IT space, even though its roots are in the industrial sector, where it was developed by a pair of IBM engineers to address compatibility and reliability issues with satellite connections to SCADA systems on large remote oil pipelines. Now, you can read more about this in one of the first articles we wrote explaining the MQTT technology via the URL shown here. Now, OPC UA is, of course, the widely used standard for integrating and establishing interoperability among multiple types of automation technologies. OPC UA support for pub-sub not only underscores the viability of pub-sub communications, but also industry's interest in it. And many automation vendors already support both pub-sub standards, MQTT and OPC UA. Common applications for MQTT tend to be for communicating data to the cloud, while OPC UA with pub-sub is used more at the controller level. You can read more about how pub-sub is changing industrial networking via the URL shown here. So I hope you found this episode of Technology Matters interesting, and that you'll check out these and other posts at automationworld.com. If you haven't yet subscribed to our channel, please do so by clicking on the AWTV logo on the bottom right-hand side of your screen. We'll see you soon with the next installment of Automation World's Technology Matters.